So I just wanted to make an example of a different approach to dividing spaces equally. And at the end of this example, I will present what I think is a much easier method than everything that I've shown so far. This is a 1-point perspective grid that originally started with a square in the center that I then added one more half to either side that was cut again to get its quarter, all to get 5 equal spaces, which I then placed out of perspective or in a draft view here underneath the perspective drawing. These are the divisions. If we start from this side, these are their locations. The next thing I did was take these divisions and move them up to scale them down. Now, the original square, which is here, has been equally divided into 5 spaces. And although this bracket might seem larger than this one, they are simply duplicates of each other. Here are the new divisions for the initial square. And here you can see these verticals connect these 2 brackets, showing that they are exactly the same. There's nothing theoretically wrong with this approach, and it works, at least in 1-point perspective. Although it technically does work in all perspectives, it becomes very impractical outside of 1-point perspective. And even in 1-point perspective, it's not efficient because there are so many other ways to achieve the same result that are easier, especially in traditional media. Perhaps an equal space divider is the easiest approach. Definitely folding a piece of paper in half and trying to get all of these 5 spaces down, scaled down to half, might be a little more difficult. But I think the approach or the concept is worth noting, since this can be the basis on how to approach other similar situations, at least in concept. Below is a 2-point perspective grid. The idea was the same here, to start with an initial square, which, if I remember correctly, is here. Then this side is simply this quarter that has been duplicated in this direction. For this side, this half of the square was duplicated and then cut in half. You end up with the same grid. This way, the square is still in the center, but these extra spaces can be used to divide the original square. Here are the new divisions. So obviously it's 3 spaces, and you can see where those limits are and where this one had an extra half. This approach will result in a cleaner drawing, not just because of this external line being within the drawing, unlike this side, but also the construction is simpler and can be made even simpler than this. The next step that I took was to take these measurements vertically. Then with this diagonal line, taking them to this vanishing point, giving you these horizontal divisions. What I did after that is take the boundaries of the original square vertically. I'm not really concerned with the height, since I'm not trying to make a cube or any kind of specified measurement. What I want is that division of thirds from this larger rectangle transferred onto the original square. Taking the horizontals going to the right vanishing point, I cut a diagonal in this new square, and where that diagonal intersects these horizontals, I take them back to the original square. Now we can see the original square and the resulting divisions. Here's the X from the resulting 45-degree diagonals within the square. Here's the geometric approach for diagonals for getting thirds, which are going to the left vanishing point. And now the original square has been divided into thirds. The benefit of this approach is that these measurements are being taken onto planes that are perpendicular to each other, which can then be transferred to many other surfaces. So it really serves two purposes, although this approach is a little long-winded and overly complicated, but it does serve a purpose. And although it does keep the square in the middle by extending either side of it, it's also more complicated than it needs to be, which I'll show in the next example. The next example is something that anyone with a basic knowledge of perspective probably already knows, but I never see talked about. It's a simple method that can divide any space or plane in perspective to any number. It does not require learning any new techniques or methods. It takes less construction than these methods and anything similar, whether it's plotting in an orthographic view or some geometric technique, and can have a lower chance of resulting in error. It also works the same way on any plane within linear perspective, no matter if it's 1, 2, or 3-point perspective. The technique doesn't change, even if the perspective does. If a drawing can be started with the object or plane that needs to be divided, then an easy approach could be to just multiply the space until the divisions or proportions are there. This is a simple approach to dividing a space in perspective that doesn't really require the learning of new techniques, and it uses a technique that is probably one of the most common, which is doubling or halving, using the X diagonals. So this is a square in 2-point perspective. The vanishing points are equidistant, resulting in a 45-degree square. Here are diagonal lines dividing the square into thirds. These diagonal lines dividing the square into thirds will be used to check the accuracy of this square divided into thirds by simply doubling some spaces. So this diagonal line is simply multiplying this half of the square, resulting in 3 halves, with the resulting rectangle being cut by a diagonal, where that diagonal cuts one of these halves going towards the left vanishing point. These lines toward the right vanishing point can be drawn, and you can see that where these new lines heading towards the right vanishing point intersect the 45-degree diagonals of the square, also intersect the diagonal lines that give us the points for our geometric thirds. Of course, this is because we have 3 equal spaces in perspective that are dividing this rectangle. And since these divisions have been turned perpendicularly to the right vanishing point, this original square is also divided into thirds going in this direction. Using one of the original diagonals, these thirds can be taken towards this vanishing point, cutting transverse or perpendicular to the original divisions. This would be the resulting square, and here's the square without the original geometric approach to dividing the square into thirds, which is completely unnecessary and was only used as a proof. So as long as you're familiar with using the X method in perspective, you can create as many equal spaces. It could be the full square, half, quarter, any division that's even, and multiplied into perspective on either side, and then those divisions can be transferred 90 degrees to the other vanishing point, or any arbitrary space that is multiplied. In perspective, a little bit of logic goes a long way.